The final transformation that we want to look at is the sinusoidal of sinusoidal functions is the period. So that is the length that it takes for one cycle to occur. We can obviously change that up. We've been looking at functions that always have a period of 360 to 60 degrees, but they don't always have to be 360 degrees. We can look at them where they're stretched out and they take more degrees in order to occur, or less degrees. They can be compressed. So what I would like you to do is to go to the following link. It's also in your Google Classroom, and play around on the Desmos calculator and look at what happens as we change the period. How does it, as we change that value, I think I called it B, that B value, how does it change your function in terms of the length that it needs in order for one cycle to occur? Okay, when you're done looking at that, come on back to this video. Okay, so you saw that as you have your B value right before your X, so it's being multiplied to the X, that is the period, the length that it needs in order for one cycle to occur. Now, just to make reference, I like to use B because now we've used the variables A, B, C, D. But in many other textbooks, and some teachers like to use K. So if you see a K, it's also still just the period. It does not matter. These are just variables anyway, so it does not matter which letter we use, but I always like to use A, B, C, D. So that's why you're going to see a B in there. Now, to determine the period of the sinusoidal function, what we want to do is we want to take 360 and divide it by the number that comes in front of that X. So before, when we were seeing, for example, y equals sine X, there isn't a number in front of that X because it's always assumed to be a 1. And so if you did 360 divided by 1, well, of course, you'd end up with 360 degrees. So in order to figure out the period that is occurring for any other function, if there is a number in front of that X, we're going to take 360 and divide it by that number, and then that will help us figure out what the period is. Okay, so let's start sketching some graphs. Let's start with y equals 3 cos x. So I'm going to begin, of course, with my base function for cos. Oops. My base function for cos. So 0, 90, 180, 270, 360, and then cos starts high, 1, 0, -1, 0, and 1. Remember, we always apply our transformations in the order in which they occur. So we start with this 3. The 3 is our amplitude. It's being multiplied to our whole cos function. So I'm going to multiply everything by 3. And 1 times 3 is 3, 0 times 3 is 0, -1 times 3 is -3, 0 times 3 is 0, and 1 times 3 is 3. And then next we have this 2. So the 2 is being multiplied to the x. So of course then we're going to have to go over here. But remember, just like before with our other transformations, when your x variable is being multiplied, we actually multiply by 1 over b. So in this case, we're going to multiply by 1 over 2, or by multiplying by 0.5. It's not straightforward. Remember, anything that happens to the x is always kind of opposite of what you would expect. So it's not a multiplication of 2, it's a multiplication of 1/2. All right, 0 times 1/2 is still 0. 90 times 1/2 is 45. 180 times 1/2 is 90. 270 times 1/2 is 135. And 360 times 1/2 is 360. The way I kind of like to think about it, like with this number in front, this 2 just means I can put 2 full cycles in a 360-degree period. And if I can put 2 full cycles in a 360-degree period, that means 1 cycle must be able to fit into 180 degrees. Okay, so now I have my points. 0, 3, 45, 0, 90, -3, 135, comma 0, 180, comma 3. All right, let's go to my graph. Oh, I'm not even there yet. I need a graph. All right, so just a sec. I'm gonna have to pull in a graph. So I'm just gonna pause my video and I'll be right back with you. Okay, so I have taken my points that were here and copied them over onto a grid. So this will be A. And now let's plot these points. So at 0, 3, I'm here. And then 45, so these go up by 30. So 45 is going to land right here. I'm at 0. And then 90, I'm at -3, which is down there. At 135, so 135 is right here, halfway in between the 120 and 150. I'm back at 0. And then 180 right here, I'm back up to 3. So notice how it compressed this cosine function so that it all fits in. It's like it squished it along our x-axis, all fit in by 180 degrees. And of course, we could keep going with this, right? So every 2.5 sections, we end up back. So 1, 2, 1, 2.5, I'm back here. Half, 1, 2, I'm down here. 1, 2.5, I'm back up here. Half, 1, 2, I'm back up here. And we could keep continuing with this pattern over and over again. I feel like I'm off a little bit. Oh, you know what? It was right there. I missed that one. Huh, isn't that great? Like when you can look at things and be so sure that you missed something or you did something off. Okay, so let me just kind of double check this again. So that was 45. So it should be every 1.5, not 2.5. 1.5, 1.5 is up here. I missed that one. 1.5 would be, so let me, whoops. Thank goodness for undo. I am not very good with. Okay, so every 1.5, I hit my next spot. So half and 1 is down here. 1.5 is up here. 1.5 is up here. 1.5 is down there. And I could continue this on and on and on until I fill the grid that I have. And so on. Okay. Whew. There we go. So it was all squished up by a factor of, so it's a vertical compression, right? So it's the change of the period. And the length of the period was 180 degrees. Remember, we can always figure out period by going 360 divided by that B value, and that B was 2, so 180 degrees. All right, let's take a look at the next one. So B, so this is going to be sine, and we are going to start with our base graph. Sine starts at 0, and then it goes up to 1, back to 0, down to -1, and then back to 0. And again, remember, we're going to read it this way. So that 2, we're going to multiply all our y values by 2, so times 2, which is going to give me 0, 2, 0, -2, and 0. And then I need to multiply by 1/1/3, which is actually going to just equal it to 3. So times by 3. And 0 times 3 is still 0. And 90 times 3 is 270. And 180 times 3, let me just double check all this, is 540. And 270 times 3 is 810. Ooh, we're not going to be able to fit much on this grid. 360 times 3 is 1080. Wow. So if I think about it, really, like this 1/3 is telling me that only 1/3 of my cycle is going to fit into 360 degrees. So it makes kind of sense to me that it's going to be really stretched out along my horizontal axis. So 0, 0, 270 and 2, 540 and 0, 810 and -2, and 1080 and 0. All right, now let me copy this and bring it over here. And let me shrink it a little bit. It's a little too big. There we go. Okay, so this is B. Pen back. This is B. We're going to do it in green. So 0, 0, 270, which is right here, and 2. And then 540 and 0. And then 810, which I don't even have on here. 720. 810 would be like off the page. It's heading down this way into the -1 area. So, I mean, we are really stretching this out. Heads in that direction. In that direction. Look at that. We were only able to fit part of the graph on it. All right. Well, let's take a look at the last one. The last one, C. Okay. Is down here. I'm actually going to change my view so I can, it's a little small down there. So let's look at the entire page. Blow it up big. All right. So coast graph, starting with my base graph. So coast starts high at 1. 90 goes to 0. 180 goes to -1. 270 goes to 0. And 360 goes back to 1. All right, again, we always read it this way. First thing I see is this 1.5 being multiplied directly to the x. So remember, it's 1 over 1.5, but I don't like have fractions and decimals together. So I'm going to go 1 over 3 over 2, which equals out to 2/3. So I'm going to multiply all these x values by 2/3. Well, 0 is good, right? Because 0 times anything ends up as 0. But 90 times 2/3 is going to be 60. And then 180 times 2/3 is 120. You can see a pattern here: 0, 60, 120. 2/3 of 720 is 180. And 2/3 of 360 is 240. All right, and then we have this +1 that's being added to the whole function. So let's go over here and go +1, which is 2, 1, 0, 1, and 2. All right, so now we have our points: 0, 2, 60 and 1, 120, 0, 180 and 1, and 240 and 2. Perfect. And again, I'm just going to copy those points so I can put them over here. All right. And there they are. Let's see if we can just sneak them there in the corner and leave them there. So this is C. 0 and 2 is here, and then 60 and 1 is there, and 120, so 90, 120, and 0 is here. And then 180 and 1 is here, and 240 and 2 is here. So there we go, right there. And I can, this actually is very nice. I can keep going with this one. So that's where my next point would be. My next point, so 2 over. I'm just working on moving 2 over. And so pretty. Fill that up. There. Okay. So there we go. So that's just a little practice of graphing while we're changing the period. Remember, when we go to change the period, though, it's going to be a multiplication of 1 over b. So whatever that value is in front of x, it's going to be 1 over that. Make sure that you adjust it as you fill your table of values. And then some homework, please give these a try out of the book or graph the following. And of course, you can always check to make sure your graphs are correct in Desmos. If you have any questions, please don't hesitate to contact me.